Welcome back. Let's do some more LeetCode today. So question 104, maximum depth of a binary tree. So this is an easy question, and this is a really good question to get our feet wet with binary tree questions. So the question is, given the root of a binary tree, we want to return its maximum depth. And a binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Meaning, let's say we are given a binary tree. So a binary tree is just basically a tree-like structure. So it's made out of this kind of nodes. So a definition of a node is basically it has a value itself, which is a number within that node, and it has a left and right node. So the reason why it's binary tree is because each node can have maximum of 2 children nodes. That's why there's the binary factor that comes in. So the left node, right, will have a left and a right itself. So you can see it's kind of a recursive structure where each node has a left and right, and each of that left and right node may have other left and right nodes itself. So given a binary tree like this, right, we want to find the deepest, what's the level, the deepest level. So in this case, it will be 3 because we have level 1, level 2, and level 3. So if we draw the diagram here, we can see, so we have level 1, level 2, and level 3. So these are the 3 levels in which we need to return. So the answer output will be 3, right? And basically, they will just give us the root node, and then we're supposed to traverse through and find the deepest. So how might we solve that, right? When we see tree structures or binary trees especially, the most useful thing to note is a recursion, right? Especially depth first search, right? Because depth first search has an element of recursion within it, where we can traverse through the tree. So basically, we'll look at each node, and then we'll try to go down to the left or right node, and then for each of the left and right node, we'll try to go down one more level. So we'll keep going down until we find that there's no more node. So in this case, when we reach 7, right, we can see there's no more left or right node. So we know that this must be the leaf, meaning this is the end of the tree. And so if this is the end of the tree, we can now try to calculate the level at which it is the end. So how do we actually do that? When we think about recursion, we should always take a leap of faith. A leap of faith is actually what helps me think and come up with recursive solutions. So when we take a leap of faith, we are trying to ask, okay, let's say given one node, how do we know its maximum level, right? We can ask, what's the maximum depth of the left subtree and what's the maximum depth of the right subtree, right? So let me repeat that one more time. If you are trying to ask, what is the maximum depth of this tree starting at 3, we can first ask, what is the maximum depth of the left subtree and what's the maximum depth of the right subtree, right? So that is the recursive part of it. So let's say we visit a node, right? We can ask, what's the max depth? What is the max depth of the left subtree and what is the max depth of the right subtree, right? And because it's a recursive call, meaning we're gonna call this max depth function on the left subtree and right subtree. And what if we get this information? So this is where the leap of faith comes in, right? Let's say the function will actually return me the max depth, right? So let's say this max depth function that we're trying to calculate here, right, max depth. Let's say it does return me the correct answer for the max depth of the left subtree and right subtree. What can we then do with the information, right? So let's say this one, right, we know that the max depth here will be 1 and the max depth here will be 2, right? Because for this node, right, you can see that there's only one level, which is just this. However, for this right subtree, right, we can see there's 1 level and 2 levels down. So if we call this max depth function on this left node and we call this max depth function on the right node, and let's say we take the leap of faith and imagine that it gives us the right answer, what can we do with these 2 information to try to find the max depth of this tree that we're looking at? We can just say, we're going to look at the max depth between the left subtree and right subtree. So we'll take a max function between the 2 functions called here, max depth of left subtree and max depth of right subtree. So in this case, the maximum number is 2, meaning that the right subtree will have a deeper level to it. So we'll take this 2 and then we'll add 1 to it, which will give us the max depth of the current node that we're looking at. And the reason why we plus 1 is because we know that this is 1 level itself. And so if my children, the max depth of my children is 2, right? That means if I go up 1 more level, it will be, of course, 2 plus 1. So that's the logic we'll go through. And if you're able to arrive this, we take the leap of faith and we find this 2 max depth, and we find the correct end condition to break out of the recursion, then it will be a really simple question to solve. So let's code through it and then you see how simple it is to actually implement. Alright, so remember, given we take the leap of faith, the first step is to take the leap of faith. So we'll take max children tree, right? This variable will contain the maximum of self.maxDepth. So I'm calling this function itself on my root.left and self.maxDepth on my root.right. Okay, so this will return me whether it will return me 2, right? Because if we assume the function works, it will take this answer and then it will return the max between 2 and 1, which will be 2, right? And then basically we want to return 1 plus max children 3, right? So this will actually give me the correct result, okay? But now we just need the base case. So what's the base case? If we are being passed a root that is null, meaning let's say we are at this where we did the recursion and we're at this node, right? And we try to take the left subtree and the right subtree, but there's no left subtree and right subtree, right? That means we are calling, see, we can call the function on, we're gonna call this maxDepth function on root.left, right? So we're gonna call this function on this node, we're gonna call it on root.left, which doesn't exist, right? So if this doesn't exist, what does it mean? That means this is level 0 because it doesn't exist. So what we're gonna do is we're gonna say if not root, meaning the node doesn't exist, we're gonna return 0. Okay, so imagine what happens, right? So let's go through the call stack and see what exactly happens. So we'll start with 3, right? We're passing the root, which is this first node 3, and then we're gonna call if not root return 0. So this exists, right? That means it has a level, so it has not reached the breaking condition. So we're gonna find the max children tree between the self-maxDepth on root left and root right, meaning we're gonna call this recursive function on this left subtree and right subtree. So let's just do the left subtree first, right? So if we call this left subtree, we're gonna come back to the function and we're gonna check if there's a root. So right now we are looking at this node, right? That means there is a node. That means this end condition has not been met. So then we're gonna call this function again. We're gonna try to find the maximum children tree between the left subtree of this node and the right subtree of this node, right? So we call it self-maxDepth on root.left. So in this case, root.left will be will null value none and will be none again. So if we call self.maxDepth on root.left, right, we'll come back to the function again, and this time we'll pass in a root that doesn't exist. And in this case, we have reached the endpoint, therefore we return 0. So at this function call of the self.left will return 0, and in the case of self.right will return 0, right? So this 2 will return 0, therefore the max will be 0. So in this case, the maximum three nodes of this node will be 0 and 0, which is just 0, meaning there is no more children, right? And then we'll return 1 plus max children tree. That means because this itself is a 1 level, and then we found that there's no children, therefore the maximum depth of this current node will be 1, right? And then if we do the same for here, we'll find that we'll come down to here, we'll call this right subtree, and then we'll call the left subtree here, and then we'll find that it doesn't have any children, right? So this will return 1, and then this will also return 1. The maximum of these two 1s will be 1. So that means the maximum depth of the children for this node will be 1. And because itself is a level, so we add 1. So meaning here, the maximum depth will be 2. And then here we return to our final stack. So 1 and 2, the maximum will be 2. Right? The maximum tree depth of this node is this path over here, which is 2. And we add on 1, which includes itself. So this will be 3. So using this recursive structure, if we try to run the code, it will pass. So it runs pretty fast, and that is the recursive definition of a tree. So I hope that recursive definition has given you a glimpse into how we can take the leap of faith to try to solve this kind of tree structure questions. So I hope that has been helpful. If you found the video helpful, liking and subscribing would help a lot. Thank you so much.